Good evening, sir.
Hi, good evening.
Mm,
Rahul ji, good evening.
uh, I think we can start now. So, welcome to the sixth online tutorial session of the NPTEL course, Polymer Reaction Engineering. So, just a second. Yeah, I'm Rahul R. I'm a Prime Research Fellow from the Department of Physics, IIT Kharagpur. Here we'll be discussing some online tutorial session where we discuss some questions and answers that you can expect for your, just a second, that you can expect for your assignments and your examinations. So let's start today's session. So today we'll have few questions, and today it's mostly fill in the blanks. True or false. Basically, this in this week we majorly discuss few theoretical parts. So the questions are also aligned in such a manner. Okay, to start with, the first question is, in a step growth polymerization, all molecules can react with any other molecules, whereas in a chain growth polymerization, monomers react at the active sites at the end of the growth chain. So this is a basic differentiation between a step growth polymerization and a chain growth polymerization, and these are the two fundamental characteristics of a step growth and a chain growth polymerization. So yeah, so just think for a while. So is this a true statement or is it a false statement? So the first statement says that in a polymerization, in a step growth polymerization, say we have a number of monomers, and this n number of monomers, or in general, if we call it just molecules, it have the um, it will like interact with each any other, and they can form continuous chain. Whereas in a chain growth, it is like the molecules will come and interact at the end of a at the end of a polymerization say, which is the active site. And so yeah, so is it a true statement or is it a false statement? Any idea?
Rahul ji, your voice is breaking.
Okay, my voice is breaking. Just a second, let me check my internet connection. Just a second.
You know, it is, I think, after some, I think resharing it is okay.
Okay, so let me check once again.
So it is true.
Yeah, it is. I can hear your voices clearly, so let me reshare the screen once again. So is the screen visible?
Yeah, it is visible. Yeah.
Yeah, and my voice, is it okay now?
Yeah, loud and clear.
Okay, thank you. So yeah, so as I said, the answer is true. Obviously, these two are the basic fundamental relations or fundamental what we call the yeah the basic definition of step growth and chain growth polymerization. So obviously, yes, it is a true. So dash is a polymerization technique where unsaturated monomers molecules add on the active sites and a growing polymer chain one at a time. I think this comes from a previous year assignment question. So yeah, definitely assignment questions give you an idea on how your examination questions will be. So that is why we are following the same trend of what the assignment questions are given. Okay, so yeah, so what is it?
So it should be additional polymerization.
Additional polymerization, yeah. Basically, here we are just talking about its step growth and chain growth. So yeah, it is at the active sites on the ground at one at a time. So yeah, let's see. So yeah, here also it's the as we this is very similar to our last polymerization technique. This is addition polymerization is also it's like it's also a step growth. It's a growth polymerization itself, but in specifically this is a specific definition for a chain growth polymerization. Here we are basically dealing with step growth and chain growth. So in that aspect, the better way to answer this question is the chain polymerization. Okay, so yeah, then let's move to next question. So what type of polymerization growth, again we are talking about step growth and chain growth, does A and B represent? So in the first figure we can see that as the polymerization step increases, the degree of polymerization is like increasing um, like linearly. So when the polymerization step, so this is a crude example, but when we look for the concentration and all, we'll get a totally different graph. But here it is an example with polymerization step and degree of polymerization. The first one says that as the polymerization step increases, the degree of polymerization is increasing linearly. Whereas we can see that the other one, the degree of polymerization, like it rapidly increases with a number of polymerization step. So what does A and B signifies?
A should be chain and B should be step.
No, it is the other way. A is actually step and B is chain, because like if you consider the number of molecules within a polymerization, we can see in step it is going one by one, whereas in um, chain growth polymerization, chains are getting added to the polymer, like
Okay,
the.
okay.
So in
Yeah,
that way, if
multi-attack
you
you
just
get
call, you just
chains
consider,
can get
yeah,
initiated.
yeah, if you just look into that aspect, it is the first one corresponds to step growth, and this is also one of the classic questions from, I think this is one is from a gate exam, and this is from chain. Okay, okay, fine.
Clear. Yeah.
Yeah, okay. Then let's move on to the next question. Yeah, first one is step growth, and the second one is chain growth. And see, these are two kinds of graph, A and B, and the B where we can see that as the concentration increases, the molecular weight initially gradually increases, then after some time it like the average molecular weight will grow rapidly. The other in the big graph we can see that average molecular weight increases rapidly, and after some time it gets like saturated, becomes like it is saturated. So which one of this corresponds to which one?
Because just this is only my understanding point of view. Probably I will put it.
Yeah,
Say if we go for chain growth polymerization, that follows that initiation, propagation, termination.
yeah,
So it will initially build up will be slow, but once the chain gets terminated, only you will get a quick build up.
yeah,
It is likely in B, which shows that trend where it is slowly, gradually increasing, and termination point of view a big build up.
yeah.
Whereas in step growth, it will be like fast reaction. After that, it will stabilize.
But I
Only
think,
flat.
but it is like what sir told, it is the actually it is in the, we can actually say this is concentration or in terms of conversion concentration, or we can also talk in terms of conversions. Just a second. Yeah, concentration, or it can be said in terms of conversion also, conversion percentage also. So actually it is in the opposite way. So what happens is here this one stands for a step growth, and this one actually stands for the chain growth. So in step growth what happens is that after some time the concentration, say you see in step growth we also say it is as a condensation. kind of reaction. So what happens is that as the reaction proceeds, there will be numerous number of byproducts like H2O, ammonia, NH3. These all will be forming as a byproduct. And as this byproducts quantity will also get increased within the reaction, and that will eventually like slow down. So yeah, so this one is actually for the um, step growth, and this one is for the chain growth. Okay, so if we take, so
Clear, clear.
in the step growth initially, as the so here in chain growth it depends on the concentrate as yeah, that's it. That's the basic
In,
difference
cha-
between.
in chain growth, initially it is initiated, then it is reached to this propagation, and after that it got terminated.
Yeah,
Like this, you mean to say?
yeah. Initially, yeah, that's it. So initially, what we say is that after a while, the step growth, the molecular weight will reach a particular value, and then we don't see like no, it is the opposite way. In chain growth reaction, we what we say is that we reach this maximum. This is the peak. The peak molecular weight would be reached instantaneously. Like it depends on the. So yeah, it will reach in immediately, and after once it reaches that particular value, then it will be like a saturated one. Okay, so the other way, for the step growth reaction, it will continue and it will keep on increasing, but after certain time, after the concentration reveal, when the concentration is maximum, it will reaches its peak. Okay, yeah, sir has explained this very well in the lectures, so please go through that also. Okay, yeah. Okay, now try to choose the correct option for the basic properties of a step growth polymerization. There are two statements given. The first statement says that a small change in the
Raghuji,
molecule.
just can you go back the earlier one?
Yeah, I think the options that I given there is wrong. That's why I didn't spend much time in that. It is what I gave you is the correct answer.
Okay,
So
fine.
here I gave is it's wrong. So the answer what
No
I
issue, no
yeah.
issues.
Yeah. So now choose the correct option for the basic properties of step growth polymerization. There are two statements given. The first statement, a small change in the molecular weight led to a higher molecular weight at the end of polymerization as large molecules of polymer bind together. Second statement is that average molecular weight is limited by the reaction equilibrium. So there are two statements. Just go through the statement and see which one is suitable for our explanation.
Yeah, here, second, I believe like we step growth, we have to remove that pipette so
Yeah,
that
yeah, we need to
reaction
remove that
equilibrium
one.
is more. So that is second statement is very clear. Average molecular weight depends upon the equilibrium, which means that removal of byproducts.
Okay.
And first one, I have a doubt.
Okay. Okay. So actually both statements are true. The first statement, which says that a small change in the molecular weight led to higher molecular weight at the end of the polymerization as large polymer molecules are binding together. So here, so yeah, these two are the basic definitions that we talk about when we, yeah. So when we talk about step growth polymerization, both of these statements, as sir said, the second statement, so definitely we need to control the molecular weight because it is also dependent by the kind of byproducts that are formed. And also we have seen that mm, uh, we have seen that molecular weight also determine the like the concentration of the last graph is so that so the last graph is so that there is a relation between this concentration and the I'm sorry concentration and the molecular weight. We see that basically the in step growth the reactions will initially it will begin rapidly, but when the molecular weight maximum molecular weight is attained, then the whole reaction process would be in a slower manner. So definitely the molecular weight is limited in the reaction, and the first one is a small change in the molecular weight is led to a higher change in the molecular weight at the end of the reactions. Okay, so that is also a true statement for the chain growth, step growth polymerization. Okay, so now this is a fill in the blank question. In dash, a step growth reaction occurs in the homogeneous molten matter at a temperature above melting point of the polymer. So here we are basically talking about the melting point. So, so there are basically we have learned about all these four types of polycondensation reactions. So, uh, in which one of this polycondensation growth mechanism we form a homogeneous molten polymer where we melt the polymer at its melting point. So yeah, please go through which one do you think is the most suitable answer for this one.
So straight away it should be melted
Yeah,
polycondensation.
so that is the basic idea behind this melting polymers polycondensation. So basically we take the polymers that has to be polymerized and we heat it up so that it will melt, and in that state we allow them to react with each other, and this will make sure that the impurities that is being produced are much lesser. Since we are melting at a higher state, the impurities in this particular reaction would be comparatively lesser than the other polycondensation techniques. So yeah, the answer is melt polycondensation. So now please see this question. Which of the following statement is not true about a polycondensation? It requires high temperatures, typically above the melting point of a polymer. It produces high molecular weight polymer due to high condensation, high concentration of the monomers. It is a relatively simple and efficient method for producing certain type of polymers. It requires careful control of the reaction conditions to prevent chain termination. It is commonly used in the production of nylons and polyesters. Yeah, which of them is a false statement when we talk about melt polycondensation? Definitely, we can see from the first one, it is a true statement because as we are talking about the melt polycondensation, definitely it is happening at a very high temperature and typically above its melting point. So that is a true statement. So what do you think about the second statement? It produces high molecular weight polymers due to high concentration of monomers. And the third statement is it is relatively simple and efficient method for producing certain polymers. It requires careful control of the reaction condition to prevent the chain termination, and it is commonly used for the production of nylons and polyesters. Do you think it is the method that we generally use for the production of polyesters and nylons?
Probably that is the only statement I have a doubt whether it is commonly used for nylons and polyesters.
Yeah.
But generally, melt polymerization, we go for a melting. First point is clear.
Yeah.
Of course, it is a simple and efficient method.
Mhm.
And molecular weight of the polymers also are like when the initial monomers are high in concentration, definitely it will quickly react when it is in molten state.
Yeah.
So then a careful control of reaction condition to prevent
No, it
chain
we
termination. So
also
we
we
have
also
only
need to we also need to make sure. Yeah. Yeah, please, please.
yeah, one doubt is that whether really like chain termination is one factor which comes into picture when we go for step growth. Because some polymers we produce here, generally we leave it to a certain stage. Like for composite processing,
Mm.
phenol formaldehyde is produced by polycondensation.
Mm.
We don't allow it to completely undergo this reaction fully. We stop at some stage,
Yeah.
we call it as A stage. Then we apply over a fabric to convert it into
Yeah.
composite. So B stage and B stage. So
Yeah.
finally, complete curing happens in a thermal curing stage where we'll go for fuel curing. So
Okay.
really, I have a doubt whether chain termination is a part of this conversion. So this is a doubt only.
Yeah, actually that is a part. The major difference comes from the option B because it produces high molecular due to high concentration of monomers. It's like if we there is a one small correction in that if the concentration is very high, large enough, and that will also like it's not just the high concentration that is like producing. So high concentration also can alternately affect the entire polymerization because we have seen that the higher polymerization that will after some time it will uh, like it will also it will generally like the polymerization will actually get reduced if the concentration is larger than a particular limit. So basically the answer for this question is the most suitable, and as sir said there is a confusion actually yeah, nylons and these are also being produced by this. Actually the answer is this particular one. This is the wrong statement about within this given one.
Can you explain again this how it like
So I
it
think
produce
what
high
what
molecular weight?
yeah, I think what happens here is that like the as the concentration is large enough, it will reach the saturation level fast enough because byproducts are also being produced. So I think this one is the false statement among them. Okay, yeah, yeah, I know this one is not very clear answer. So yeah, let's think on it. I think this is
Just just
yeah.
just
Just
like
please think.
just
Let us discuss. Yeah, please.
I'm just asking
Yeah,
if
please.
a reactant having like a high concentration,
Hmm.
there is a, suppose a monomer having high concentration, when it undergoes some polymerization,
Yeah.
if it like some kind of condensation or in terms of
Yeah, I
even
think what happens
byproduct
is
we are
that
getting.
I think what happens
Mhm.
here is that the high concentration itself will act as in like it will try so as the concentration also increases, the kind of by like the products the product to reactant ratio as it increases, it will then lead to generally the slowing down of the whole reaction process when the react like the
Yeah, it
product
may
part
slow down. It
yeah.
may slow down,
Mm.
but it is necessarily not necessarily. It should
Not
be
necessarily.
like low. It produce high molecular weight polymer.
Yeah. Mm,
It should produce, I think, like if monomer is already high concentration, so
mm,
it may undergo some kind of condensation or simply a
yes.
polymerization, step growth or chain growth.
Yeah.
The 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 polymer that will be having high, it may reach to high viscosity because of numerous
Yeah. Viscosity is also a
reaction.
part. Yeah.
Uh,
Yeah.
may
That is
may
also a
undergo
reason.
several reaction
Yeah. Yeah.
may
Yeah.
undergo several reaction, and if we don't terminate it, so it may reach to high viscosity. So
Mm,
the
yeah.
molecular, for me, what I'm like asking,
Yeah.
it
Please.
should, it might be have a high molecular weight
Okay.
to like. Mhm.
So can I ask you one doubt like this? Can it be like that? So if there are high concentration that will lead when it melts, it can also lead to a higher uh, viscosity, and then that
Yeah, my doubt is
yeah
that
yeah
it may, it should, it I might be like not so much about this how it could be
mm,
necessarily low molecular weight.
yeah. So which
It
one do
should,
you
it
think?
should be high molecular.
Yeah. So which one do you think should be the answer? I what out from this I felt it was B. So what do you think should be the answer? Hello?
I'm not so certain about other options.
Yeah. Other option if you
Uh,
consider this the first one is perfectly true.
yeah,
And
perfectly true. First one is perfectly
this is
true.
also true statement. Here we are just we are not doing like we are providing just providing heat and nothing but and also we need to this one is also a true statement because this is a clear statement from sirs lecture. So there was so this one is also a true statement. I was having a doubt only particularly on this one. So and what I felt is that this one should be the answer. Yeah. Okay, let's think over it. So yeah, this is about polymer.
Yeah, yeah, yeah,
Yeah.
yeah, yeah.
So I think the major reason come with this viscosity part, like the concentration increases, and when it melts, that can somehow inhibit the whole reaction process. Okay.
Are you certain about point E, this
Yeah,
nylon and polyester?
yeah, I have checked that. I've just cross-checked. I had also that confusion. Then I have cross-checked that one.
Okay.
Yeah. Okay. So a chain growth polymerization is used for synthesizing class of adhesives and amorphous solids called epoxy resins. So do we use chain growth polymerization for the synthesis of adhesives and epoxy resins? Do you think this is a true statement or this is a false statement?
Should be false.
Yeah,
Generally, we prefer step growth.
yeah, very true. We generally prefer step growth for this one, so this is a false statement. So we go for step growth in epoxy resins. Okay. Okay, to promote the removal of byproducts from a polymer melt, dash condition may be applied to remove the volatile byproducts. So here also we told that here also there are many volatile byproducts will be formed. So what is the general way we use to remove these byproducts? Do you remember? This was well explained in the lecture.
Generally, we go for vacuum distillation by
Yeah,
application of vacuum or
yeah,
by purging.
yeah. So we go for the so we use vacuum conditions will be applied to remove the volatile byproduct. We just remove the or air or water particles within the reactor, and we try to create a vacuum condition. Yeah, the polymer products obtained by melt polymerization are generally contain unavoidable impurities. So do you think this is a true or a false statement? Do you think in general the products obtained by the melt polymerization is impure, or like there are many unavoidable impurities that comes along with the polymerization? Do you think this is a true statement or is a false statement?
It should be false. Generally, it is melt means it should be pure.
Yeah, yeah, I think I agree with sir. Generally in melt, the major advantage of this melt polymerization technique is it generally produces a much more higher or much more pure products. So basically this is a false statement. So generally it produces a pure products. Okay. Yeah. Dash factor makes the removal of small byproducts from a viscous uh, reaction mass process of rate control in a polymerization reaction, especially as the conversion increases significantly, leading to substantial increase in the viscosity of the reaction. So what factor makes the removal of small byproduct from a viscous reaction a mass process? Maybe just consider as a difficult process. I think there is some problem with the question. As a mass reaction mass, a process of no viscous reaction process. Okay, I think I don't know where this mass came from. Viscous reaction, a process of rate control in the polymerization reaction, especially as the conversion increases significantly, leading to the substantial increase in the viscosity of the reaction. Any idea? So something increases. Yeah,
High viscous. If it is high viscous, then it will be difficult to.
yeah. So that's the reason. See, if initially the increased viscosity in the conversion will act as a like controlling factor, rate controlling factor in this polymerization, melt polymerization reaction. So that is what I think is the answer for the previous question also. So I think when the reaction start, the after some time it will become more viscous, and then that will act as a rate controlling process. So I think it is the viscosity, increase in the viscosity after, while the conversion would make the entire process, or will act as a entire rate controlling process in the polymerization reaction. So the answer is increase in the viscosity with conversion. Increasing viscosity. Viscosity Viscosity will act as a rate controlling factor. Okay. So dash polycondensation is employed in industry to synthesize polyurethanes, polycarbonates, and certain sort of polyamides and polyesters. So which kind of polycondensation is employed in this one in the industry level?
Usually solution, maybe there is a good thing is that we can control the viscosity,
Yeah,
and with low viscosity solvent involved, solution polymerization, we can have better control of viscosity heat transfer.
yeah,
It is likely the most preferred method.
yeah. It is the solution itself. It is a solution polymer. So how do you think the assignment questions are for the previous year? So, so was that question clarified? The last class where the one student was telling about there is a problem with one of the questions. So is that clarified, or do you know anything regarding that?
Not issue here. I was not aware of that. Probably
Okay. So what do you think, like the
this is okay. Actually, whatever we are seeing in the classes are really useful
okay.
to solve the assignments.
Yeah, mostly I'm depending on the previous year assignment questions and some questions that are related to those assignment questions, so that thereby you'll be getting a good understanding on like how the questions would be. So you can expect similar kinds of questions in the assignments, and similar questions will be definitely asked for the examinations also, because yeah, you may see some questions seems to be much simpler, like mostly it will be fill in the blanks or true or false. So basically it will be, as we all said, like it is catered for a wide student from a different background, hence the in general NPTEL courses would be more in a broader manner. Okay, so yeah, so let's go on to the next question. So the solution polymerization is generally used when, first one, keeping reactants within the same phase is difficult. Second, when melting point of the resulting point polymer is very low. So which one do you think is the correct statement? This all come from the basic definition of the polymerization techniques. Like when we talk about polymerization, we generally, so these are the basic conditions which we where we consider this solution polymerization. So the first one says that it is difficult to keep the reactants in the same phase, and hence we go for polymerization, solution polymerization. And the second one states that when the melting point is much lower, very small melting point, uh, yeah, in that case also we go for the solution polymerization. Do you think these two statements are true, or these are, yeah, please?
At least the first one, it is clear because keeping reactants within same phase solution is preferred. When we are having gas phase reaction, some of the gas we can dissolve in the liquid phase under pressure. So it will be preferable to carry out such reactions through solution.
Mm,
And when the melting point of the resulting polymer is very low, maybe that is not correct.
yeah,
Where we are looking for slightly higher melting point.
yeah, that's it. So the first one is true. So when we so we use this, so we have other kinds of polymerization techniques like bulk polymerization in that and all. So in that and all, see, uh, yeah, so in the comparing to that, in generally, if we have, or if we need to keep the reactants, if it is difficult to keep the reactants in the same phase and all, we generally go for polymerization. But the second point is actually wrong. So it should happen, it should be when, like, it should be in the opposite manner, when the melting point of the resulting polymer is very high. In that case, we generally go for solution polymer. Since here it is at low, so we can go for many other techniques. Even we can go for melt polymerization technique if the melting point is much lower. So here is the melting point is much larger. So hence, other kinds of polymerization techniques are not much useful in this. So I think the answer should be A is true and B should be false. So I think it is the option A that is correct. So yeah, it is. Next question is, The dash reactions are diffusion limited, and therefore the system is typically stirred to ensure better contact of the two liquids. So here we say that there should be some kind of contact between the liquid, and it definitely says that the liquids are somehow separated and you need to do this stirring, and hence, and why they are why do you need to do it? It is a diffusion. The diffusion will be limited in the layers. So what kind of reaction will
Interfacial
happen is,
reactions.
yeah, interfacial. So the major is interfacial. So forgot to turn on.
Your sound is breaking.
I don't know. The internet here is, I think there has been some problem from yesterday.
Sometimes your sound
Yeah,
gets
it is.
break,
I think
and
it is
sometimes maximum
breaking.
time it is okay.
Yeah, they are just rewiring the whole Wi-Fi system here. I think it is something related to that. Yeah. Okay. So this is the basic idea behind this interfacial system. Here in interfacial, we consider two liquids basically that will form an interface. And yeah, they form an interface because there will be a difference in their viscosity and all. So then they are basically diffusion limited, and therefore it should be stirred continuously so that there is a proper contact between these two liquids. And hence, this is a typical. The answer is interfacial reactions. Okay. So here also it is a true or false statement. The two statements are given. The first statement: the materials employed in interfacial polymerization need to be utmost purity. So here we are talking about the purity. So does it require, so in interfacial, uh, does the purity matters? That's the first question we need to think of. The second statement: therefore the polykondensation takes place rapidly at low temperature and atmospheric pressure. And in like interfacial polykondensation, the uh, polykondensation takes place rapidly at low temperature and atmospheric pressure. So which one do you think is true? I think this is from a last year's assignment question.
Statement one is false.
Statement one is false. Yeah, correct. This first statement is false. What do you think about the second statement?
I think two is right. True.
Yeah, we are basically talking about interfacial polymerization. The first statement says that it should be of pure purity. It should be a very pure solution. So that need not be a condition for interfacial. But another property of this interfacial is that it can take very rapidly at low temperature and atmosphere. We don't need to take it to its melting point or any such high temperature or any such non-ambient condition need not be provided. It can happen in the ambient atmospheric conditions itself. So that is the correct statement. The answer is option, I think it's option B. The statement one is false and the statement two is true. Okay. Now let's go for this next question. Polymer separation from solution, recovery of solvent, and polymer washing and drying are required in the interfacial polykondensation. So do you think these are the properties for interfacial polykondensation or not?
It should be for solution.
Yeah. So the major thing is in
We have solvent oxide.
both of them we are talking about some kind of solution. In one, the solution forms an interface, and the other, the idea is different. So do you think this is applicable for interfacial polykondensation?
It's true.
No, actually this one is true for not interfacial. This is
Solution.
as sir said, this is a statement for the solution polykondensation. In the solution condensation, for these steps are we need to get the our product polymer, and then we need to wash it to remove the impurities formed, and then we need to dry to remove the water content or the solution content from it. So these are the typical procedures that one will follow when it is a solution polykondensation reaction. And yeah, so this is for and
But
not for this.
but uh, in this actually, like when I was going through, it
Yeah,
was saying in an interfacial polycondensation,
yeah.
The polymer formed are filtered, washed, and dried.
I think
It is actually
okay.
given.
Okay, so yeah, I think
Yeah,
maybe it will be
agreed.
difficult.
Actually, there is a filtration, washing, and drying is there as a part of interfacial
Okay.
to take care. But whereas the recovery of solvent, because generally solvent is added in solution polymerization to ensure that what we can say like uniform or reduced viscosity. So there, after say polymerization is over, we have to recover the solvent for next batch. So huge quantity of solvent goes in for a solution polymerization. One example is like polybutadiene reaction where we use butadiene gas phase. We dissolve in isopropyl alcohol solvent, an initiator being hydrogen peroxide. So after the reaction completes in the liquid phase, IPA will get separated out from the polymer, and that IPA we will not throw. We will recover by distillation and reuse.
Sir has a lot more experience in that topic than me. So yeah, thank you, sir. Thank you for your input. So I think that is clear for you. Hello?
Okay. So the answer is false.
Yeah, answer is full. And as I said, the recovery of solvent is the major difference from that of interfacial and as a solution polymerization. Okay, so that was also an information for me also, sir. Thank you. Okay.
This one
Okay.
phase we are using for synthesis of one binder resin, so that's why I highlighted this. Thank you.
Yeah. Okay. Thank you. Thank you, sir. Okay. So let's go for the other question. The question says that
Can you
yeah, please,
just
please,
sorry to
please.
interrupt?
Yeah, please,
Can you
please.
go back to the last? Go back to question number 16.
Yeah, please.
Polymer separation from solution,
Mm,
recovery of solvent.
mm,
Uh, Here, the polymer separation from solution has been indicated.
mm.
So, but it is the formation of polymer we are talking about, right?
Yeah, it says that once the required polymer is produced, we need to separate it from the solution, and we also need to recover the solvent, and then we need to wash uh, the product
What
polymer.
means the polymer that has been formed
Yeah.
in this process, polymer separation from solution.
Yes.
That is the polymer which is formed from the solution
Yeah.
are washed, dried, and that are required in the interfacial polycondensation.
Yeah. So yeah, I didn't get you. So what do you?
I actually it is actually I have a problem. Actually, sir was explaining, so in that I could not like properly get it.
Okay.
It is mentioned कि polymer it is already there. कि polymer formed at the interface are filtered, washed, and dried.
Huh.
Here also polymer separation from solution, like it
Mm.
is like little bit twisted from the like in the statement. Polymer
Okay.
separated from solution, like we can consider polymer formed from the solution
Mm-hmm.
and solution, recovery of solvent,
Mm-hmm.
and polymer washing, drying are required in interfacial polymerization. So which is I think this is matching with the statement which is there already in the
So do you think
interfacial
the second
polymerization.
statement is also true for interfacial
Yeah, I
polymerization,
think I
recovery
think
of the
I'm
solvent?
just
But I think I
yeah.
took this from the, no, I am sure that I took this from the solution polymerization part itself. Okay, so this is a statement. So I'm not sure, like if I might have missed somewhere. So this the same step is set for the
Solution.
yeah, solution also. I mean for the
One
interfacial
more
also.
point I will add, probably
Yeah,
this is just a general information only.
yeah.
So when we see for this solution polymerization, generally, say for example, I can convert a gas directly into polymer by bulk polymerization where I don't need any solvent. But problem is that there actually the reaction as it propagates, it will end up very high exothermicity will be there. So control of that reaction generally will be a problem. So there I can choose a common solvent where this gas reacts, because definitely when I use a gas, there should be an initiator. So the initiator will be in liquid phase and gas phase. I will select a common solvent where this both will dissolve. But once the reaction propagates, there is a point at which it terminates, like by termination by two combined big chains combining and joining together. Like multiple steps were there for termination, like multiple ways were there rather than steps, multiple ways it can terminate. But once this polymer is formed, the polymer to certain extent, maybe low molecular weight polymers will be dissolved in the solvent as such, whereas this high molecular weight polymer after means more than certain molecular weight comes out of the polymer phase. So we will get a two distinct phase. One is resin and this solution. And when we recover this solution, that will be a huge portion of this polymerization polymer. We need not throw it because that will still contain a low molecular weight fraction in it. So that cannot be reused for the next step. So to remove that low molecular weight fraction, I have to go for a distillation where I will recover and reuse. So this is one part.
Understood.
When we see interfacial polycondensation, generally that is required where we go for very high, like what we can say, like interface part of it, like reactions. So there I think that the what we can say that that is something like the reaction happens in the interface. So there definitely whatever the polymer we prepare, that needs washing, because if at all any impurities is there, that needs to be removed by washing, then drying to get the what we can say final product. Whereas
There
the
is no
other,
fraction.
there
Understood.
will not be any fraction, but it will be like a polymer where you have to simply wash it to remove the impurities. Whereas here it will be low molecular weight as well as high molecular weight, and low molecular weight preferentially comes within the solvent itself. So that recovery is more critical when we go for solution polymerization, huge quantity, because sometimes the solvent what I referred as IPA. Per batch, it may be almost like more than say 50% of the total batch volume will be this solvent.
Okay.
Understood, sir. Understood.
Okay. Thank you, sir. Yeah. So I hope it is clear. Yeah. I'm working and so I don't have this much experience as sir is like having a 20 years experience in this
Yeah,
Nothing
field.
like
me as
this.
well. Me as well.
Nothing like that. Actually, since it is one area where I was there for some
Okay.
time, that's why.
So
Yeah,
that's
please.
the experience. Okay. Okay, sir. I think like we can move on to our next question. Okay. So the next question, the irreversible exothermic polycondensations that involve in the formation of a side product utilize this polycondensation techniques. So this one is true for which kind of polymerization polycondensation technique? So we have different kinds of polycondensation. Which one is best suited for this? The irreversible exothermic polycondensations that involve in the formation of side product and utilize this polycondensation technique. So what is this referring to? So which kind of a polycondensation has this kind of a property?
Is it emulsion?
Yeah, it is the emulsion. So this is the basic idea for the emulsion polymerization, polycondensation technique. Hmm. So the next question is, dash polycondensation is utilized for making reverse osmosis membranes and encapsulation of inks, insecticides, and medicines. So which one is the polycondensation techniques that is generally used in this kinds of applications? Media. So there definitely where we talk about reverse osmosis, definitely which one do you think it should be? That is the clear thing from here. I think we need to,
Interfacial.
yeah, definitely. It is the interfacial. Right? It is interfacial polycondensation that is generally used for making reverse osmosis membranes and yeah, insecticide medicines. So this is the answer. Okay, now let's move on to our next question. So the pellets in a solid state reactor are held at high temperature above dash but below the dash of the polymer that makes the functional groups a functional N group mobile to react. So which are the, so here basically we are talking about two temperatures regions. So which one do you think should be those temperature? In solid state reaction, the temperature are basically held between these two temperatures. This one also is a basic characteristic for a solid state reaction, where we generally, what is the basic temperature we keep.
Is it the held at temperature above the glass transition temperature?
Yeah. So the base is glass transition
Okay.
temperature, and what is the maximum it can go?
Below the melting point.
Yeah, that's the answer. So it can go to glass transition temperature, and it should be below the melting point. Okay, so that is the answer. That is the general criteria we follow in a solid state reaction. Okay, the rate of a step polymerization can conveniently express in terms of concentration of the reacting functional groups. Is it a true statement or a false statement? Can we express the rate of a step polymerization by the concentration of the reacting functional groups? Is it a true statement or is it a false statement?
Probably true, but probably this particular section I have yet to go through. Maybe this is only from my understanding. Probably because I think two more lectures are there for me to go through. So
Yeah.
that's why.
Okay, so yeah, so your understanding is true. So it is a true statement. So yeah, so we can actually determine the rate of a polymerization, step polymerization by the concentration of the reacting molecule. This is a true statement. Okay, the yeah. So the next question: higher molecular weights are indicated by greater values of dash. So here we
One more small
The
clarification.
question number, the serial numbers are not in. Actually, this should be the question number 20 or 21.
okay.
Earlier it was 20.
Yeah, maybe like
18. After that, it should
I'm
be
putting it
19.
manually. So sometime I might have
Yeah,
missed.
yeah.
Yeah, please.
Okay, okay, understood,
Yeah,
understood.
sometime when we're preparing, I might have missed something. So higher molecular higher molecular weights are indicated by the greater values of dash. So what from by observing something, we can say we can actually correlate that with the higher molecular weight. So what is that property of the reactants?
Whether it
Or
is degree of realization.
no, here actually we are talking about the viscosity. As the
Oh,
inherent,
viscosity, viscosity.
yeah,
Okay.
as the inherent viscosity changes as the if the inherent viscosity is larger, then we can say that the molecular weight of the particular polymer is also higher. Okay, it is the
It's a
inherent.
viscosity.
Yeah, it is a viscosity. The viscosity, if the higher viscous of a higher viscous polymer generally corresponds to higher molecular weight polymer. Okay. Okay, in batch reactors, I think, yeah. In batch reactors, the reactants are charged, followed by mixing thoroughly and react for a certain time period, then discharge after complete reaction. This is a true or false statement.
True
True.
statement.
Yeah, definitely. This is a true statement. We have seen already these kinds of questions, so this is a true statement. Okay, so try this question. select the correct option from the correct option for the important. So we have already seen that there are certain assumptions made. Okay, so the first statement is that the reactivity of one of the functional group of a bifunctional molecule is same respective of whether the other functional group reacts or not. The second statement is that the reactivity of a functional group is independent of the size of the molecule which is attached. The third statement is these assumptions are referred to as the concept of equal reactivity of the functional groups. So these, as Sir was talking about the reactivity of the functional group, he had talked about basic assumptions. Okay, there are multiple assumptions made before we start talking about the reactivity of the functional groups itself. So yeah, these are the three assumptions that are given. Do you think these are true? Are these the assumptions that we initially take, or is it different? Just read the statements once again and try if you can recall. The first statement states that the reactivity of one of the functional group for a bifunctional molecule is same irrespective of whether the other functional group reacts or not. Okay. The second statement is that the reactivity of a functional group is independent of the size of the molecule, okay, to which it is attached. The third statement is these assumptions are referred to as the concept of equal reactivity of functional groups.
Sorry, here I am yet to go through. Probably I may not be able to pick a right option.
Yeah.
I'm
So
doing
yeah,
so, it will be incorrect.
definitely. I took this question because definitely the answer is all the statements are correct because these are the basic assumptions because uh, before we start talking about this functional reactivity of the functional group, like all the statements which are said are true. Okay, I think yeah, when you listen to the lectures, RS explained this very well. So yeah, definitely please try to go through the lecture. So these are the basic assumptions which we took before we start with the step of like the reactivity of the functional groups. Okay. So which of the following statement is incorrect for the importance of solvents in the polymerization process? In presence of strongly porous solvents such as DMSO, higher molecular weight polymer can be obtained. It helps in the accessibility of functional groups within the reduction in viscosity of the mass reduction. It influences the rate of polymerization and the molecular weight due to the preferential solvation or relationship with either reactants or transition state of reaction. This is useful when the melting point of the resulting polymer is low. So where we use what is so this talk about the importance of solvents. So I think sir will be able to answer this particular question. We are talking about an incorrect statement, which is the incorrect statement. I think this is obvious because we have seen a similar question, and from that we can definitely say
The second is clear. It helps in the accessibility of functional group with reduction in viscosity of reaction mass. Because solvent plays a major role in facilitating the viscosity reduction so that functional group is easy to access. Like as I already told, like hydrogen peroxide, once it gets into radical form, it will be easy to initiate a gas phase also. That is, B is clear. Then it influences the rate of polymerization and molecular weight due to preferential solvation with either reactions or transition state. That also is uh, true because actually the molecular weight is primarily controlled by this solvent. Why I'm selling is the same example. because low molecular weights are preferentially getting dissolved in the solvent. And if I want a tailored molecular weight, I can easily tailor by allowing some of these molecule or low molecular weight to be in the liquid phase. So only those high molecular weight chain, if it is there, that I can put it, and I can control the rate of reaction. Also, if solvent is there, the rate will be different. If solvent is not there, the rate definitely it will be different.
Yes.
And then when it is useful, when melting point of the resulting polymer is low. When melting point of resulting polymer is low, I'm not clearly getting it. Melting point of the resulting polymer is low. So which means where only I have a doubt. But the first one also, strong protonic solvents such as DMSO, high molecular weight polymer can be obtained. So this is generally for polysiloxanes from silicon, like silicone resins. We end up with high viscous resins. So there actually DMSO is the preferred solvent. So first also I will go with that.
So I think the last question, last one can be said as incorrect because we are talked about this addition of solvents in the solution-based polymerization. In that, generally, if we talk, uh, it is generally used in solution-based polymerization, like solution polycondensations are generally used when we have the melting, we have the melting point is high. So the answer is option D. This is the incorrect statement among this. Okay, the solvents are generally used when we need to actually control the viscosity, and uh, and also it is used when we are dealing with high molecular weight with high melting points. So I think option D is the answer to go for. Okay,
Yeah, clear.
so here we say that the melting point is low, but here actually we go use this when the melting point is high. So that is the basic difference. So we say when the actually it should be like the when the melting point is much larger. In that case, we generally go with the solvents. So I think it is clear. Yeah. Okay. So let's go to the next question. The equilibrium constant for a polymerization reaction is 0.04. Then calculate the corresponding degree of polymerization. So here we need to know the equilibrium constant, and then the relationship. Basically, we need to know the relationship between the uh, equilibrium constant of polymerization reaction and the degree of polymerization. So if we know, then definitely that is a very easy question. Any idea?
Now you're ready to go through.
Yeah, then I can tell you the relation. So relation, we generally denote the equilibrium constant by K. So this is basically represented by K, and the corresponding degree of polymerization is represented by Xn. Then I can write Xn as 1 plus K to the power 0.5, or it's like the root of 1 plus K. So then it should be root of 1 plus 0.04. Then it is root of 1 plus it is root of 1.04. So what should be the answer? It's like the root of this 1.04 to the power 0.5. Yeah, it comes around 1.0198, which can be approximated to 1.02. Okay, so the basic relationship between the degree of polymerization and the reaction rate is given by this one. Okay, so in examination, definitely they can ask in a reverse manner. They may give you the degree of polymerization, and then the other thing can be asked to calculate when xn is provided, and then we are asked to calculate the value of k. Okay, So is
Is it? I just want to ask one
yeah,
thing.
please.
Is it xn equals to 1 plus k to the power half or whole to the power half?
Whole to the power of.
So,
The equation is correct. Xn
okay,
is
so it's a closed system, right?
yeah 1 plus whole to the power of.
Is it like if a equilibrium constant for a polymer reaction is 0.04, it's
Yeah.
a closed or open? Is it mentioned anything like that or?
No, I think I took this question from a previous year assignment, so the answer should be correct itself. No, okay. I think I have made a mistake. Like it is, yeah, I think, thank you. So I think I have made a mistake. It is 1 plus k to the power half. Okay, so then the answer is 1 plus 0.404 whole to the power 0.5. Then again, the answer comes to be same, but
Answer is 1.2.
yeah, 1.2, 1.02, right? 0.4, 0.4 to the power half. Yeah, it's 0.02. 0.2, right? Yeah, it's like 0.2, not 0.02, it's 0.2. So answer is 1.2. Yeah, I'm sorry. It is not the has of power, so I just made a mistake. It's like k to the power.
Okay.
Yeah.
Okay.
I'm sorry. Thank you. I'm really thank you. Okay. So let's go to the next question. So which is incorrect for control of the molecular weight in a linear polymerization? So which one do you think is the correct answer for that? The first option is molecular weight can be controlled by quenching of reaction at required time. So we're talking about linear polymerization. Which one is the wrong statement? By using one react higher in amount than the other reactant, one reactant in higher. So we say that one reactor is made to react higher than the other one. The next question is by addition of monofunctional monomer, the addition of bifunctional monomer. So which one do you think is the answer? So we are particularly talking about linear polymerization. That is one. Yeah, I think I already disclosed the answer. So yeah, it is
It's like
bifunctional.
it's,
Yeah,
it will not allow to terminate. It will again further allow to continue
yeah.
on the either
Basically,
side.
since this is bifunctional, it can also form parallel chains. So then the whole linear polymerization will go, and then it will become there will be cross linkings happening in between, and the linear nature of the polymerization process itself will be affected. Okay. When a bifunctional monomer comes in between, it can cause other polymerization, cross linking to happen, and the whole linear nature of the polymerization will be lost. So yeah, so the answer is addition of bifunctional monomer. Okay, so
Yeah,
let's
quenching the reaction is sudden cooling of the reaction, right?
yeah we we can
When there is
control.
some kind of exothermic reaction or any kind of reaction which is having heat evolution,
Mm-hmm.
so we cool the reaction by sudden cooling.
Yeah, okay,
Okay, that's why it has been mentioned quenching of the reaction at required time.
okay. So that can also be used to control the molecular weight. So what
That one, that one,
what
that one,
brings the
that one.
confusion? What
Understood.
brings the confusion?
No, 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 I'm just asking.
Yeah,
Here the quenching terminology has been used.
yeah,
So
definitely.
is that meaning to suddenly drop the temperature of the reaction?
Yeah, I
For
think
that, this quenching has been used.
yeah, a sudden control in the temperature is given, but is it at a very high temperature? That should be noted, like is an exothermic reaction. That part I have some doubt, but quenching basically corresponds to bringing a sudden control over the temperature. So is it because of the exothermic reaction that is happening? That part I have a bit confusion. I cannot give you answer
Okay,
clearly.
okay.
Yeah.
To control the temperature, you meant
Yeah,
to say.
basically you will control the temperature. We'll control, we'll suddenly, we won't allow it to go after it. Once it reaches a particular, we just control it. Yeah.
Okay.
Let's try the next question. So the number of average degree of polymerization is given by number of the average degrees of polymerization is given by the total ratio of total number of molecules initially present and the total number of polymer molecule. The ratio of total number of polymer molecules and total number of molecules initially present. Product of total number of molecules initially present and the total number of polymer molecules. The ratio of the molecular weight of the polymer divided by the molecular weight of the individual repeating unit. So which, or there can be multiple options also, correct? So which one do you think are the better definitions in order to see the number average of degree of polymerization? Just go through which one do you think are the better suited definition.
Maybe the D1, now ratio of molecular weight of polymer divided by molecular weight of individual repeating unit.
Yes, that is correct, and also the option A is also a correct option. The ratio of the total number of molecules initially present and the total number of polymer molecules. So that is also
Whether that is like a where ratio of total number of initial molecules present is with respect to the monomers, and that is divided by total number of polymer molecules.
yeah. I have a slight doubt here. See the first one and the second one. What is the difference happening? The ratio of total number of molecules initially present and the total number of polymer molecules. The ratio of total number of polymer molecules and the total number of molecules initially present. Both of them represent the same one, no?
Yeah, exactly. Yeah.
Yeah.
No, no, B is different.
No, no,
B
ratio is
The
different.
ratio.
Numerator is different and denominator is
Yeah.
different for
Okay.
both the
Okay.
case.
Yeah. Okay. Fine. So actually, yeah, the first one. Then the first one is also is a definition for this. So this one is straight from the previous year assignment. So this one is a correct statement itself. I think something has happened. Yeah, I think this is a first option
Answer
is
is A and D, right?
A and D. Answer is A and D. So these two are the correct answers. Okay. So I think these are the questions that I prepared for today's class. So basically this week we had a much more theoretical aspects and the questions were also basically from the theory. So you just need to know the theory and the numerical part from this is much lesser. I think the numerical parts are coming on the next lectures.
In some of the lectures, there are so many numerical part also explained.
The first one,
So,
basically that
yeah,
came,
yeah, first two lecture, yes.
yeah, because since sir
Part one
is
and
already
part two.
explaining the answer also, that's why I didn't look into
Understood,
that
understood. So,
aspect. Yeah,
can we expect same questions in the exam also?
yeah, you can definitely expect.
Actually, the length of the questions, like answers are so big.
Yeah,
So,
so, but definitely the final answers. I don't think like that will be for a very small percentage of questions will maybe come in that manner. Basically, see if you see the assignment as I was
that
just
doesn't
going.
look
No, no,
marks one question.
no. That definitely they will keep some kind of grading for the questions also in order to sort the students. So that would be like maybe one or two questions of that kind of a range, and basically mostly the questions you can see from the assignment itself. The questions would be of this much level itself in the examination point of view. Because as
Understood.
we said, like not all are from the chemical engineering background who are taking this course. People from different kinds of background who are like getting an introduction to this course will also be learning
Yeah,
things like that.
myself, I'm having mechanical background.
Okay. I'm having a
It's
background of
completely,
physics.
completely different thing for me. This
Yeah.
one.
I'm having a background from physics. That's why in some parts I find it a bit different. Whereas Shravan sir is completely from this background, so he have a good understanding on what is happening. Yeah. So that's
Not
good.
that way. Anyway, it is good that good to see people from different background are trying to get the understanding of this. Because
Yeah.
when we joined, initially we also not have much familiarity with the polymer aspects, because chemical engineering we generally don't study too much into the polymer chemistry, only as an elective.
Okay.
But when we joined our working nature, we get some experience on this, and then it probes into we probe into that. But really,
Yeah.
from a different background like physics or mechanical background, when we are trying to understand this chemistry and involve in that, means it is really appreciable
Yeah.
for both of you.
So the way we look
Thank you.
into the
Thank you,
aspects will be
sir.
different. Like as far we are considered, maybe we may not be so much familiar with the kind of chemical reactions that is happening. So we'll be looking at from a different perspective. And sir has a basic understanding of the chemistry, then the way you look will be also very different. Yeah.
It is like collective learning. We
Yeah.
learn together. Okay.
Yeah. Uh, Last year also I was taking one online course, and that was from much more from physics aspect. So, but the interaction, the students were having a very low interaction, and after few classes, the number of students that are actually getting was much low. In some classes, there were no students also. But I'm happy to see that there's an active participation from at least both of you. So thank you for that also. I think these questions will definitely be useful for your assignments and for examination, as this being a
Sure, sure.
course
Because
which
that way,
is
what our Partha Saradidi also telling, we can like this is one way where we are trying to have our what can say, like basic understanding getting improved. Because there are certain things when we see chemical reaction engineering, we do study the kinetics of the reaction, but combining these two will be we will be getting more understanding. So both polymer chemistry plus reaction engineering, it is a new mixture. So that will be like a new understanding we can gain, and we can refresh whatever we studied earlier.
okay. Okay then. So definitely I will try to bring up with some good questions, and the next time I will try to reduce the mistakes that I'm already making in the presentations. Okay,
No,
so
it's
then
completely okay. Actually,
yeah,
actually, we also like. If you ask me particularly, I liked your class. To
thank
be
you.
honest.
Thank you so much. Like this is also a very good learning curve for me also.
Also, I get to learn from the sir also.
Yeah,
Whatever
definitely.
discussion happens in between the questions, and whenever it comes to in terms of practical way of understanding, it's really delight to know such things.
Yeah, thank you. Okay, then I think
We
we
are
can
going
leave
to
on
thank
the
you very much,
thank you.
both of you.
Yeah.
Shall we? Yeah.
Yeah, then we can leave for today and let's meet on the next class. I will
Yes,
try
yes,
to
yes.
add more number of questions so it will be much more helpful for you.
Thank you.
Okay.
Thank you.
Okay,
Bye.
thank you so much. Okay, bye.
Thank you. Thank you. Thank you.